All right, so let's take a look at this formative here. This first one just used the basic power rule, add 1 to the power and divide by the new power. All right, so x to the 4th over 4 plus 4x plus c. All right, put that away and check your own. All right, don't forget the plus c's when you're doing indefinite integrals, okay? The second one, the only way that you guys can do this one would have been to FOIL out the top. Then I reduced everything, okay? You could have rewritten it all as 3 separate fractions and reduced each one separately. But notice x squared over x is just x. The 4x over x reduces to 4. And then I put this last 4 over the x as well. And now we have something that we can take the integral of. Right? So we had x becomes x squared over 2. The constant 4 is now 4x. And here we need to see this as 4 times 1 over x. And the integral of 1 over x is ln of x. So it's 4 times the ln of x. Make sure the 4 goes on the outside, because the constant would be 4 times the integral of 1 over x. Was that your question there? Okay. So, yeah, just so be careful with that one. And then, of course, plus c. All right, any questions on the first two? All right, good. Number three here, we have a definite integral, so we need to take the integral of x to the 1/2 power. So you add 1, now it's x to the 3/2, and then you multiply by the reciprocal of the new exponent, so it's times 2/3. So that's how we got this, okay? And then we need to use the fundamental theorem of calculus. So you'll see here I'm evaluating at 9 and 4. Okay? So when I evaluate it at 9, I get 2 times 27 over 3, which is 18. Okay? And when I evaluate it at 4, I get 2 times 8 over 3, which is 5 1/3. So we subtract then. Remember, it's f of b minus f of a. And we get 12 2/3. Okay? Just a quick note. Remember, if you're doing the 3/2 power, remember that's cubing something and square rooting it. And you can do those in either order. So in this case, it would have been easier to square root the 9, you get 3, and then cube the 3. And that's how we got the 27. Square root of 4 is 2. 2 to the 3rd power is 8. Okay, so that was that's how we would have done number 3. Okay, does that make sense?
Yes.
All right, number 4. Taking the integral, the indefinite integral part was pretty simple. Okay, it's 2 functions added together, so you're just integrating each one. The integral of sine is negative cosine. The integral of cosine is sine. And then we need to find the integral from pi over 6 to pi over 3. So by the way, here's a good example of, this wasn't an IB question, but this is the kind of thing you might see where you've got to incorporate the old trig stuff into the new calculus stuff. All right, we can't think of these topics as separate entities. We have to think of it as one whole body of knowledge that we've got to pull from. So we have negative cosine of pi over 3. Cosine of pi over 3 is 1/2, so it's negative 1/2, plus the sine of pi over 3, so that's root 3 over 2, if you remember your unit circles. I would not be surprised if something like this were on like the non-calculator part. Okay, they're going to give you all ones that work out to unit circle stuff. All right. So that's our f of b, this whole thing right here. Minus, here in the brackets you see f of a. So negative cosine of pi over 6, that's a negative root 3 over 2, plus the sine of pi over 6, which is 1/2. So we simplify that all. It's negative 1 plus root 3. If you want, you could make it a decimal. It would be 0.707. approximately, okay, or you could round to 0.71 for the 2 decimal points. But leaving answers like this, a negative 1 plus root 3 is perfectly acceptable, okay. All right, so there's number 4. Then I'm curious to see how you guys did with 5 and 6, since you had the video yesterday and you did some practice. Okay, so let's take a look at this one more closely. Then we'll also take a look at the practice you did yesterday in class and whatnot. So one thing to understand, remember the integral of the derivative will give you the original function. All right, so here we're integrating the derivative and using the rules that we know. It's 4x squared over 2 plus ln of x plus c, which is just, 2x squared. But now we're given this point that when x is e, our function has to equal e squared. So we need to figure out what that constant is that will give us that. So we plug in e for x, and the whole thing equals f of e, which is e squared. Okay? So you can see here, ln of e is 1. 4e squared over 2 is a 2e squared. If I bring everything to the right-hand side, I subtract, and I get e squared minus 2e squared, so negative e squared minus the 1. Okay? So that's the constant. And please remember to write your final answer. Okay, don't just stop once you get the constant. Now we know that our function, f of x, is 4x squared over 2 plus ln of x minus e squared minus 1. Okay? I don't know why I kept writing that as 4x squared over 2. Let's make that a 2x squared, simplified here. Okay? So, all right, we could write this as a 2e squared. All right. So does that make sense how we got the original function there then? How did you guys feel with these when you were practicing yesterday? I know some are still catching up with other things, so it may have been sketchy, but did this process at least make sense? I know the actual integration might have been challenging, but the process seemed to make sense? Okay. Now, here's a case too where we can be given the second derivative. If you think about this in terms of the motion applications we talked about before, you can kind of see how we could come up with formulas for other things. For example, like your velocity is a rate of change. If we wanted to model, say, the volume of something as it's being emptied, if you know the rate of how fast it's being emptied, like, a gallon a minute or something, that's your f prime of x. And then you could integrate that to figure out what the actual volume was. And if you knew what the max was, you could have like an expression for that. Here, think of it in terms of, we might know of a way to calculate the acceleration of something. And we know at a moment in time, its velocity was 6, and at another moment in time, it was located at the point 2,5. All right? So if you can pick out some information, then we're able to integrate. First of all, we integrate the second derivative, and that will give us the first derivative. That's what we're doing here. Okay? So we integrate this. To integrate this, we have to FOIL it out. So it's x squared plus 6x plus 9. The integral is x cubed over 3 plus 6x squared over 2 plus 9x plus c. Okay? That 6 over 2 we can reduce down to a 3. And you'll notice I do that down here. Once we get to the derivative function, it is reduced. But notice I took this point 3, 6 that was on the derivative, and I plugged in 3, and I made the whole thing equal 6. And we solve and we get our constant equal to a negative 57. Okay? So now we know what the derivative is, so we can integrate the derivative to find the original function. Okay? We take the integral of this derivative, x to the 4th over 12 plus x cubed plus 9x squared over 2 minus 57x plus c. And again, now we're going to use a point, but this time we're going to use a point that's on the original function because we're trying to find the original function. So we need to know what that c would have to be for the original function. So I plug in 2 because that's what x is on the point that we know. And I plug in 5 for f of x. And we solve it. We get 91 2/3 for our constant. So now we can take the integral that we had before, we plug in c, and now we know our final answer, what that original function would be, or the position function, if you will. Okay? Make sense?
Yep.
All right. I know it's may sound easier, when it's being explained to you. I know it's challenging stuff, but just keep working through it. All right, and don't give up on this.